Hello, I'm Professor Rad, and today we're going to talk about order relations with fractions. So just as a reminder, an order relation is a less than or a greater than or an equals to. So we've done this with natural numbers and integers and decimals. So today we're going to talk about how you can do that with fractions. Remember that in a fraction, the numerator, the top number, represents how many pieces you have. And the bottom number, the denominator, tells you how big the piece is. So how big, the slice of pizza is, or the piece of chocolate you're eating is. So if we're going to compare fractions, we want to be able to compare amounts. But in order to compare the amounts, we have to make sure that the size of the piece is the same. So our strategy that we're going to talk about today, this method will always work, is first we're going to see if they have the same denominator. If they don't, we're going to find a common denominator for the two fractions and rewrite them so that they have that common denominator. Once the denominators are the same, then you can compare the amounts and then decide which one is greater or less than, or if they're equal. So we've got several examples that we're going to work through just to practice this. So for part A, I'm going to check first, do they have the same denominator? Yes. Oh, magnificent. So when the denominators are the same, just compare the top numbers like you would with normal numbers. So 15 compared to 7. 15 is bigger than 7 is, so that means that 15 24ths is greater than 7 24ths. And that kind of makes sense, right? If I had a pizza that was cut up into 24 pieces, and you had the same size pizza also cut up into 24 pieces, and I ate 15 pieces and you ate 7, I definitely ate more pizza. Okay, so let's look at this next one. So this next one, I noticed that we have the same numerator for both, but this time the denominators are different. So it doesn't matter the amounts that we have at the beginning. At the beginning, we want to make sure the sizes are the same, and these are not the same. So we've talked about a few different techniques for finding common denominators. So I'm going to use, for this example, I'm going to use the prime factorization method, since these denominators are pretty small and my factor trees should be pretty small. For example, 15 is going to split into 3 times 5. And 12 is going to split into 2 times 6. And then 6 will further split into 2 times 3. So 12 is my smaller denominator, so I'm going to use that as my base. And then I'm going to pick up any factors over here that aren't already listed. So this 3 can match up with that 3. And then there's a 5, which this one is missing. So I'm going to toss in a 5. 5 times 2 is 10. And 3 times 2 is 6. So 10 times 6 gives me 60. So a common denominator I can use here is 60. So I want to rewrite 7/15 to have a denominator of 60. And I want to rewrite 7/12 to have a denominator of 60. 15 goes into 64 times, and 4 times 7 is 28. 12 goes into 65 times, and 5 times 7 is 35. Whew. Okay, so notice the difference in work. Part A, when we already had a common denominator, easy peasy. If we don't, sometimes there's a bit of work to do. But now that the denominators are the same, we can compare them. 7/15 is the same as 28 out of 60, and 7/12 is the same as 35 out of 60. So 35 is the bigger amount. So we have the same size, 60ths, and 35 is bigger than 28. So that means 7/12 is bigger than 7/15. So 7/12 is going to be the bigger fraction. In other words, 7/15 is less than 7/12. All right, let's do a few more examples together. Okay, so for part C, I've got 8/7 and 35/49. So, bummer, my denominator's not the same. Good news is, however, that 49 is a multiple of 7. In other words, 7 goes into 49. So I can use my second method of getting a common denominator. I can use 49 as the common denominator. That means I only have to change one of the fractions. So I've got 8/7 times something to get me 49ths. Well, 7 goes into 49 7 times. And 8 times 7 is 56. So 8/7 is the same as 56/49. So I can compare my 56/49 to my 35/49. 56 is bigger than 35, so 8/7 is greater than 35/49. Cool. All right, so this next one, we have 30ths and we have 9ths. So we've used the other two methods of getting a common denominator, so let's use the easy one here. To get a common denominator, you can just multiply the two denominators. 30 times 9 is going to give us 270. So I've got my 17/30 times something. It's going to give me a denominator of 270. And 4/9 times something is going to give me a denominator of 270. Okay. These are some big numbers. So let's bring our friend over here. 270 divided by 30 gives me 9. So I'm going to multiply the bottom and top by 9. And then 9 times 17 gives me 153. For the second fraction, 270 divided by 9 gets me 30. And 30 times 4 is 120. Cool. So 17/30 is the same as 153 2/70. And 4/9 is the same as 120 2/70. So now that the sizes are the same, can you imagine cutting a pizza up into 270 pieces? My goodness. But the sizes of our pieces are the same. So now we're going to compare the numerators. 153 is bigger than 120. So that means 17/30 is greater than 4/9. Okay. And we're going to keep on using whichever method we like to get a common denominator. So for these two, I'm going to use that method. I don't mind working with the big numbers, especially because my calculator is here to help me out. So I'm going to go ahead and find common denominators for these two fractions here, and also some common denominators for these two fractions down here. And then I will rewrite my fractions and compare them. So if you want to, you can go ahead and pause the video and work that out on your own and see how you do. Yeah, you can unpause and check your answers. So I'll see you in just a moment. Alrighty, let's see how we did. So for part E, I actually got that the two fractions are equal to each other. And for part F, I got that the first fraction is actually just a little bit smaller than the second one. So let's go through my work and see if it matches what you found. Excuse me. So what I did here was I did 65 times 91, and that gave me 5,915. So 65 went into 5,915 91 times. And when I multiplied the tops, I got 6,825. For the second fraction, I did 5915 divided by 91 and got 65. And then that gave me 6825 for that numerator. So with the denominators the same, I noticed that the numerators were also the same. So since the numerators were the same, the two fractions must be equal. For the last one, I did 44 times 21. That gave me 924. And then, I did 924 divided by 44 to get 21. 21 times 23 gave me 483. And then 924 divided by 21 gave me 44. And 44 times 11 gave me 484. So 484 is just a little bit bigger than 483. So that first fraction is just a little bit smaller than the second one. Now, as we've been going through, you might have noticed some things about some of these fractions, and you might have been wondering, yeah, but can I just do this or do that instead? So in the next video, we're going to talk about some tips or tricks that you can use so that you don't have to use this method. The reason I like this method of getting a common denominator is because it always works. So I'm somebody who has trouble like memorizing lots of different things. So the more I do something and the more like regular it becomes, then it's less like memorizing and more just like, oh yeah, this is a pattern I recognize. So when I'm first learning something, I like to use a method that always works because it's like, I learned that one thing, one and done, I know I can apply it. And then over time, if I need to, as I recognize those patterns, then I can start to take some shortcuts. But if you're the sort of person who likes to take shortcuts, because you are good at memorizing or remembering lots of different techniques, then that's what we'll look at in the next video. But before we get there, I've got a few problems that you can try out on your own to figure out which of these are less than or greater than. So I hope you found this video helpful, and I'll see you in the next one with a few tips and tricks. Bye for now, everybody.